Okay, good morning to everyone. And I'm assuming, Debbie, that was still Crosby, Stills, and Nash. And Judy Blue Eyes, which is one of those defining songs for that group. We're going to do some review this morning. We are nearly done with our computational review. We are going to finish that this week. That means we're getting close to a midterm. Okay, that's a test on all 18 reviews. It's 400 points, and it's a major part of your grade. Okay, and that's coming up next week. This week, we finish up the computational review, and then a reminder. There is a final at the end where I expect you to remember everything we've done in the Orange book. Okay, so that's another major test, and that'll be only on the Orange book. We've done counting. Today we're going to see what we can remember about counting. So here's your first problem. You need some paper out. Now I want you to hold on to this because these are reviews that we're going to do each week now because we need to keep this in our head. It gives you some problems to look at. I want you to count from 1 to 100, base 3. Count from 1 to 100 in base 3. Let's see if you can remember. From 1 to 100 in base 3. And then we'll do it on the board in a moment. Okay, some of you are finished. That's good. Still waiting for the pencils to stop. That'll tell me that you're done. Okay, here goes. 1, 2, tell me the next one. 1, 0, not 2 O's, 1, 0. Okay, 1, 0. Then 1, 1, 1, 2. 2, 0, 2, 1, 2, 2, and here's 1, 0, 0. How many got it? Okay, not everybody. Feel better if everybody had it. But that's something you're going to have to do. Another one in base 3. In fact, I think I'll make it base 5. We'll change to base 5. 2, 3, 1, 4. Write it in expanded notation. Expanded notation. And again, I'll give you a moment. See what you have. Now, on any of these problems, that if you look at them and you're not sure what to do, it's a good time to get some help, ask some questions, but this is just an effort to review from the counting unit. What is the first thing I have to worry about here when I do expanded notation? What do we worry about? What do I have to know? Anybody? I need, okay, what kind of values? You're right. Called the place values. I need that. Okay, so let's see what we have. We have 2, a 3, a 1, and a 4. Place value first digit, a 1s. Your place value in the second digit is always what? Well, always the base. So that comes down here. Now, what do I always do to get new place values? Multiply by the base as I go to the left. So what does this one become? 25. And then 5 times 25, you're 125. Now, what option do I have instead of writing 125? Yeah, 5 to the third instead of 125. So I have the option of writing 125 as 5 to the third, 25 as 5 to the second, the 5 is 5 to the first, and the 1 could be written as 5 to the 0. That's an option. Okay, so let's write what we have. We have 2 times 5 to the third. I have 3 times 5 to the second. I have 1 times 5 to the first. And I guess I'll erase what I had there because I ran out of room. And then I have plus 4 times 1 or 5 to the 0. Can you tell me what that is in base 10? Can you get me the base 10 number? It's not 2314. That's a base 5. What is it as a base 10 number? What do I now have to do? Going to add them together after I've done what, though? Multiply. So sometimes we, now this is where I would rewrite the 5 to the third as 125, and then the 5 to the second as the 25. And what do we get? Okay, so Adrian's saying 434. Let's see if we buy it. Thank you, Debbie. 250 here, agreed? Then 3/4, 75, a nickel, and 4 pennies. A group of 10, and 4 leaves a 14. Then I carried the 1. That's going to give me the 13. Carried the 1, and nearly. Okay, 3. What did we say? 334 then? Do we agree now? This is in base 10 now. So this is a base 10 number, base 10 here, but base 10 here, but base, sorry Debbie, base 5 here. Okay, one last question. What digits do I use to write a number in base 4? What digits do I use to write a number in base 4? That's my question. What digits do I use? Good. 0, 1, 2, and 3. Very good. Now that covers 4 different questions from counting. And on the final, I would have about 4 questions from counting. So if you have these and you say, okay, I've got that, I would be inclined to write each of these questions on a 3x5 card and save them. Now I'll be coming back each week doing some review like this for the problems in the orange book. So if you just keep a deck of cards and write these problems down, and then shuffle them from time to time, write the problem and the solution on the back side. Then shuffle the deck and go through them. It might help a lot as you get ready for the final. And I know, we're just into week 6, but we're 1/3 of the way through the semester already. Okay, it goes quickly at this point. Next thing you know, you'll be eating turkey and doing Christmas shopping. I said that to Sarah this weekend, and she didn't appreciate it. Time's going too quickly. Formulas. Okay, let's see how we can do in formulas. I'm going to write 4 of them up here. Let's see if you can get these 4. I just handed you back a short quiz we took on formulas. Now, I won't use the same ones I did there, but I'll use some of them. So for the first one, I want the area, just write these down, area of circle. Just write me the formula. Remember, you need an A in front of the formula. Don't forget the first name kind of response. Adrian. Okay. Area of a circle. That's the first one. Second one, area of, and I'm just going to draw a picture, right triangle. So area of right triangle. Circumference of circle. I'll just draw a circle. I need to get this base 10 a little bit tighter. So I'll leave that there so I can get one more. Okay, volume. My effort to draw a sphere. Okay, those are your 4 formulas. Let's see if you can get 4 for 4. Four for 4 is the goal here. I want the formulas. Okay, who can give me the area of a circle? Now, you said that like you had a question. It was pi times radius squared? What do you think, folks? Pi r squared. Okay? So, yes, pi r squared. You know, there's a little bit of humor in mathematics. Not a lot. But are you familiar with the way that you can sort of remember this one? It's a little bit of mathematical humor. Are pi squares, when you think of a pi? Pi are not squared. Pi are round. Cornbread is square. I didn't say it was a big humor, but there's supposed to be a little bit of laughter at that point. But it's a nice way of remembering. Pi r squared. No, pi r round. Cornbread are square. Pi r squared. Now let you try to get that out of your head tonight. Okay, what about the area of the triangle? Who's got that one? Again, one of those question marks at the end. Okay? Anybody else? Do you agree with the response given? I won't repeat it yet. It was asked as a question. Do you want to state it as a fact? No? I mean, you got to go down in a blaze of glory. I mean, right or wrong, you were correct. It was base times height over 2, or 1/2 base times height. Okay? That was the area of a triangle. And by the way, any triangle. The height is called an altitude. Now, when you have a right triangle, this is the height I'm pointing to. It's one of the legs, and the base is the other leg. Not all triangles are 90-degree angles, or right triangles. Okay, who's got the circumference of the circle? Lewis, were you giving me a number, an answer?
09.
Pi.
Pi.
Pi. So it is 2 pi and what? And r. 2 pi r. What's another way of writing it? If you take 2r, pi times?
R.
If 2r, what is twice the radius called?
Square.
No, it's not r squared. That's r times r.
Pi.
2 times r is the diameter, d. So you could think of this as pi times d. You eat the pi? Pi d, d pi? Okay, that one was no good either. Okay, what about volume of a sphere? Going for this one. Who's got this one? Okay, is this going to be with a statement or with a question? With a statement. Oh, with authority. Go for it.
3 over 4 times pi times r cubed.
Okay, I heard very clearly pi r cubed. You know, I had some hearing there that I had a hearing loss when you said the fraction. Let's see if I should hear it.
Oh, wait, yeah, it's 4 over 3.
4 over 3. Thank you. 4/3. It's more than 1. Might tweak that just a little bit, Debbie, so I can just a bit. Thank you. 4/3 pi r cubed. Did anybody get 4 for 4? 3 for 4. 2 of you. 3 of you. That's not good enough. Spend time on those formulas. Okay. Last part of the review here. Rounding off. Here's my number. 374.369. And I'm just going to walk off camera for a moment here. You can see the directions. Let's see what you get as you do that. We'll just leave that up on the screen. Maybe pull in just a little bit tighter and get rid of the blue there if we could. I don't know if we can. Yeah, that's better. I like that. Round to nearest hundredth. Notice the TH. And then round to nearest hundred. No TH. We'll just give you a moment to do that. Again, what I'm waiting for here is for the pencils to quit moving. So once we get the answer written down, we can compare and see what kind of result we have. Okay, the pencils seem to have come, for the most part, to a stop. So as we come over here, let's see what we should have. Now, on this one, to the nearest hundredth. Where is my hundredth position? What digit's there? Tenths, hundredths. So this is my hundredth position. I look to the right, and if it's 5 or more, what do I do with the 6? Go up. So it becomes 374.37 to the nearest hundredth. Now, the question, if I put a 0 after this, is it wrong? The answer is yes, it is wrong. Because a 0 here would say I have it to the 1,000th, and I wanted it to the 100th. So you can't add anything after the 7. Okay, what is it to the nearest 100? Go to the hundreds. Remember, this is ones, tens, hundreds. Check next door. It's 5 or more. So we up the 3 to a 4. And now be careful. What do I now do? The 0, 0 before the decimal, and stop. In the same way, you couldn't have a decimal point with what? Zeros after it, because you would be giving a mixed message. You'd be saying hundredths, not hundred. Have we got it? Okay, Debbie, you're ahead of me. You are just way ahead of me. I'm going to ask Debbie to go to the sideboard. We have some things over there that I want to address because they are related to place value that we just talked about. Now the language, again, this becomes 1 over 1,000, right? Now question, in the place values, as we went to the left, what did we multiply by? 10. But if we go to the right, what do I divide by? A 10. The exponents will become negative. But I'm going to divide by 10 as I go to the right. So that's why when you divide 10 into 10, you get 1. 10 into 1 becomes 1/10, and so on. Let's write these as exponents. This is 10 to the third, because it's the number of zeros after the 1, correct? The next one is 10 to the second, 10 to the first. You only have 1 0. How many zeros do I have after this? 0, so we call that 10 to the 0. Now, notice I stair-step down. 3, 2, 1, 0. So what happens here? 10 to the negative 1, 10 to the negative 2, 10 to the negative 3, and so on. Now, you just have to keep that in mind as we look at problems, because I'm going to segue here briefly into another notation. Now, what notations have we talked about so far? What 3 notations? Expanded. What else? We're talking about notations. What 3 have we done? The first, expanded. Okay, I'll take that. What? Okay, verbal. What else? After verbal, one more. What? Yes, positional. Thank you. That was in the first review. And then there's a fourth one I'm going to throw in called, now that's an interesting 4, Debbie. Put a 4 with a parentheses all at once. That was my effort. Not well done. Scientific notation. Now, we have a whole unit we're going to do in this, but I just wanted to point out that we use these ideas with the exponents up here, so maybe we can just climb up a little bit more, just a little bit more. There we go. So, for example, I can write a number this way, 1.56 times 10 to the 5th. That's called scientific notation. Now, this 5 translates into 5 zeros after the 1. So that's 100,000. And so what this does is move the decimal point 5 places to the right. So you're going to find that that's what you get for taking this number to positional. So the decimal was right here, and I went 1, 2, 3, 4, 5 places before I got the decimal point. And so we would say, what in verbal notation? How would you read this? 156,000. Now I'm going to change the problem to this. Now notice the exponent becomes negative 5. Now what does that mean? If this is 10 to the minus 3, and it means 1 over 1,000, 10 to the minus 4 would be 1 over 10,000. So 10 to the minus 5 is 1 over 100,000. So this means I have 1.56 times 1 over 100,000. So what am I doing here? Dividing by a power of 10. So if I'm dividing by a power of 10, the decimal goes to the left. And what I'm going to get, okay, if I have 1, where do I want to do this? I'm trying to think in terms of space. I guess I'm going to crowd this in here. Don't want it there. I'm going to put the 1 here, and then I'm going to back up 2. So 1, 2, 3, 4, 5. And so the decimal went 5 places to the left when I had a negative exponent. Positive exponent, the decimal went to the right. So this brings me to 2 rules with decimals. If I multiply by a power of 10, move the decimal point to the right. And what's the other part of this? 10 to a negative, or we can think of dividing by a power of 10. So if I divide by a power of 10, move the decimal point to the left. Now those, let's just slide over now just so we can see this, Debbie, and just pull that in a little bit tighter. Thank you. 2 rules. So the 2 rules have to do with multiplying or dividing by a power of 10. Now I'm going to look at 2 problems. A multiplication problem and a division problem. And let's see if you know the rule we use and why the rule is given the way it is. So that's my question. Now here's the problem I'm going to write. And please note it's a multiplication, but also note I did not line up the decimal point. When is the only time I need to worry about lining up the decimal point? When I add and subtract decimals. That's the only time I have to worry about that. I could have lined this up, but it wasn't necessary. Now, what is a rule that most of you remember when we do a problem like this? I hope we remember some rule. What are you supposed to do? Count what? You're correct. I'm going to count something. Okay, the number of places behind the decimal is a good way of stating it. How many digits here after the decimal point? I have 2 and 1 here. So I add those together. So I have 2 here, 1 here. I add that, and so 3 digits have to be after the decimal point. But what do you usually say to a person if you were telling them how to multiply with decimals? Well, first you might say, forget about the decimals right here. I'm just going to multiply these 2 together. And in fact, I think to make this a little bit easier, I have 4s there. I'm just going to make this 1.2 instead of 1.4. Now, what do I get? 288, correct? I'm just totally ignoring the decimal for the moment. Then I mark off a spot, and I get 4, 4, and 1. We've done enough of these that I hope this is straightforward. And so you get this, 1728. Now my question, what do you tell the person if they ask, how do I locate the decimal point? What do you tell them? Anybody? Give me a response. What would you say to somebody when they're saying, how do I get the decimal point in the right spot?
Start from right to left, count 3.
Okay, I'm going to count these 3, start because the decimal's here at the end, correct? And so you think of going to the left 3 places, putting the decimal here. We don't want 2 decimals in it, so I get rid of this last one. And so we say you move the decimal what? To the left 3 places. Now let's look at our rules here. We multiplied, correct? But my rule says what? If I multiply by a power of 10, I was supposed to go to the right. Why did I end up going left here? That's the question. So I'm going to look at these 2 numbers. If you were to read verbal notation, 1.44 you would read as 1 and 44 hundredths. And you're multiplying that times 1 and 2 tenths. But what do we do when we're multiplying with mixed numbers? change them to improper fractions. So this becomes 144 over 100. This becomes 12 over 10. Multiply that. I'm not going to cancel. So what do I have in the denominator? 10 to the third. And up here I have 144 times 12. Now we said that multiplication gave you this. So it was really what? Okay, I guess that looks about as, maybe tweak just a bit to try to get this at the top, just so we can get a little better readability. A little bit more. There we go. Much better. Thank you, Debbie. Now notice, what am I doing down here in this last step? Dividing by what? A power of 10. And if I divide by a power of 10, move the decimal point to the left. Just tweak a little bit to the left here. There. If I divide by a power of 10, move the decimal point to the left, and I'm walking off camera for a moment, and I want you to look at what we have there. This last step was really what? 1728 over 10 to the third, so that's why I moved this decimal over 3 places. Same rule. I moved to the left because I was dividing by a power of 10. Okay, let's slide over a little bit further, Debbie. Now, technically, we don't do this problem yet. I think I'll leave it as it was just to convert back. We said we have 1728, and I had the decimal where? Right here. Okay. Now, I'm checking my work. Just a reminder. If I know, and let's slide over just enough I can pick up right here, Debbie, because this is how we check a multiplication. Most people don't like checking multiplications this way. Take a reverse, inverse. If these multiply together to give this, then when I divide the answer by 1.2, I should get what? 1.44. Now, does someone remember, and I can see already, Debbie, that that's not going to be big enough at the distance we are to read well. That's better. What rule do you remember when we do a problem like this? What's the rule for division? Do you remember a rule that you use here? Okay, I'm not getting much of an answer. Does this look familiar? Okay, I'm going to get rid of the decimal point in the 1.2. This problem really means that I have 1.728 over 1.2. It's a fraction. Every division can be written as a fraction. But I don't know, well, let's put it a different way. I don't like that decimal point there. How can I get rid of it? I can move it. What allows me to move it? Multiplying by 10 to the first. Remember my rule. Let's slide over, Debbie. Slipping and sliding. If I multiply by a power of 10, I'm going to move the decimal point to the right. So if I multiply by 10 to the first, coming back over, I move the decimal one place to the right, and if it's at the end, it no longer is written. So I'm at 12 now. What does your basic principle of fractions tell you? Okay, what I did to that denominator, I must do to the numerator. So that gives me what? 17.28. Now I know how to do that problem. And isn't that what I accomplished here? But why did I move the decimal to the right? Because I was multiplying by a power of 10. So there's a consistency. Whenever you multiply by powers of 10, decimals go to the right. Whenever you're dividing by powers of 10, decimals go to the left, the other direction. Well, let's see what we now get. And by the way, you must remember to bring that decimal point up. Now, I'm going to need a little more clearance up there, Debbie. Just maybe tweak it. There we go. 12 into 17. The 1. What's left? A 5. So I have a 52. That's a 4. What's left? 48 from 52 is a 4. And there's my other 4, and I'm done. Now, the rule involves an actual division in this problem, because I really had, in terms of this division, a multiplication by a power of 10. Let's slide over just a bit. When I multiplied here, I was really at the end dividing by what as we drop down just a smidge? Dividing by a power of 10. So maybe just over to here and there, and I'll come off camera. Those two problems tell it all. So the question, what do you do with the homework problems you have? So we're going to go to lesson 16. Remember, there's only 18 in this review. And we are right now at 16. Let's come back to that for a moment. Multiplication of decimal fractions. And I think I can scoot that over just enough to get nearly everything in. Now, on this first page, which is 155, I'm doing exactly what I had on the board. Same idea. I'm not going to restate that. But there is a nice set of rules for locating the decimal point when you're dividing. It says multiply the numbers, and let's come out there for a moment, Debbie. Let's see if I can get rid of some of the curving there. There we go. We multiply the numbers as though there were no decimals. Count the number of digits to the right of each decimal. Add the two counts. We did that. And then position or locate the decimal point so that there's that many digits after the decimal point in your final answer. So we're moving the decimal to the left because we divided by a power of 10, even though we're doing what? Multiplication. Now we're going to have a similar rule to that for division, but this is page 156. Now there are times when it pays to consider how you're going to multiply two numbers. Let's look at this one. This is on page 157. Now, I've written down the number of digits after each decimal point in this problem because I have 4 digits after the decimal point with the first 0.003, that's up here. And then I have what? 1 digit down here. Now, this is not the best way of doing that problem. I have what? 1, 2, 3 lines I have to go through. But if I rewrite it, just reversing the multiplication, notice 1 line and I'm done. So think a little bit of the order that you're multiplying and make sure that you're comfortable. Now, this is a problem that, because we focus on decimal points, doesn't make sense to us sometimes because if I don't have that decimal after the 7, and I ask you to count how many digits are after a decimal, it's an easy part up here because there's 2 digits there. But if I just have a 7 without the decimal point, you don't even see the decimal point. You have to think of writing it in and how many digits after the decimal. 0. So you add here and you get 2 in the answer. And I multiplied and located the decimal point. I have, as we move that over, the same problem but without the decimal point after the 7 because most people would not write the decimal point in there. But it's understood to be there. Okay? The results are the same. Now what about multiplying by a power of 10? I'm down at the bottom of the page on page 158. Okay, Debbie? Now here's my problem, and again, let's come off there for just a minute. I keep getting a slight curvature I don't like. Now let's try it. Now notice in this problem that here I have 1,000 times 4.17, but over here I rewrote it as what? 10 to the third times 4.17, and what is my shortcut? The decimal goes 3 places to the right, okay, and so this is what you're going to see, 4,170. So anytime I have a 1 followed by a lot of zeros multiplied by another number, rewrite the 1 followed by the zeros as a power of 10. Let's look at it again. So I'm rewriting the 1,000 as 10 to the third. Okay? Okay, coming off there. When I do that, I'm moving the decimal point that many places to the right. So let's look at the same idea on page 161. And this is D. There we go. What am I going to do as my first step here? Rewrite the 10,000 as 10 to the fourth. And then what do I do at the decimal point? I'm going to then move this decimal here after the 7 to the right because I'm multiplying by a power of 10. So I want the intermediate step. But down here, the problem is already written with what? A power of 10. So what can you do? Move the decimal point over and give me your answer. Nothing else needs to be shown. Is there any question in that? Now this is just a question, what do you do with decimal points when you multiply by powers of 10? And my concern is that you try to avoid the confusion of when I go to the left or right. Anytime I'm multiplying by a power of 10, I go to the right. Anytime I divide by a power of 10, it goes to the left. Think of it this way. If you're multiplying by a power of 10, the number must get larger. That's what happens when decimals go to the right. When you divide by a power of 10, the decimals go to the left because you want the number to be smaller. Okay, let's go back to review test 16. Now tomorrow we will be doing the division with decimals. It's going to pull together much as we did today. But then on Wednesday, we're going to do percents. And we're going to do decimals and percents and common fractions all at the same time. And that does become, for many, a little more difficult than some of the things we've been doing recently. I'd say number 6 and number 18 have about the same level of demand. And then I guess it was what, about 12 where we were finding LCDs. Okay, here's review test 16, page 213. Be careful in this. Read the problems very carefully. When it says find the sum, it's telling you what operation that you must add. Now notice in this first problem, are there any decimal points in the numbers? No, but are they there? They are there at the end of each number. Coming off that, this one I think there's less confusion because if you look at this problem, you see decimals in each number. What's your rule? Line up the decimal point if you're adding. Finding differences. Again, you're going to line up decimal points. Be careful after this 3, 7, what might you want to put in? You have 14.37, only 2 digits after the decimal point. I would be inclined to add a 0 there. So 14.370. Number 2A, or 2B, I'm sorry, this is the trap. We talked about this, I think, on Wednesday or Thursday of last week. What's your trap here? There is a decimal point after the 23. We don't write it typically. So I would put 23 point with the 2 zeros. Good. As I come down to problem 3, finding the product means you're multiplying. What do you have to be careful of here? There's no decimal in the 37, but it's at the end. So there's only one digit you're going to have after the decimal in your answer. The next one, I can't tell you which way is necessarily the best. Both numbers have 3 digits that aren't zeros, non-zero digits, 3. It's a toss-up which way you want to multiply this, but how many digits must be after the decimal point in the answer? 4, because you have 3 here and 1 here. Coming off there, this one, just a reminder that there's no decimal after the 525. That's very typical. So you just have 2 digits after the decimal in that. But I didn't take you off the hook here. How many digits after the decimal point in this one? There should be a big 7. Finally, so I look down here at 5, part A. What are you going to do first step? Okay, change the 1,000 to a power of 10, and then simply move the decimal place. Coming off there, finally, this one is 100. So again, you're going to write it as a power of 10, and then move the decimal point. Okay, now, with that said, that's due tomorrow. Then, we'll do division tomorrow. I'd like you to continue reviewing a little bit with the material and the counting unit, the formula unit, because when we finish this, we start reviewing for the midterm. And we'll have a couple days we will just do midterm reviews, and you'll be doing a lot of work in class while we go through problems. And then you have the midterm to take. So at this point, midterm probably next week sometime. So start thinking about that, trying to get ready for